Imagine witnessing a celestial spectacle so magnificent it could outshine the entire galaxy. That's right. We're talking about the enigmatic star, Betelgeuse, whose recent dimming has set the scientific community abuzz with anticipation. Could this be the precursor to a dazzling supernova event? Join us as we unravel the secrets of these explosions and their profound impact on our universe. From the birth of stars to the cataclysmic end of their lives, we'll delve into the captivating world of supernovae and explore the forces that shape our universe. But wait, there's more. Throughout our journey, we'll invite you to share your thoughts and questions in the comments below. After all, what's a voyage through space without a little camaraderie among fellow space enthusiasts? So buckle up and get ready for an exhilarating adventure beyond the stars. Don't forget to hit that subscribe button to stay tuned for more mind-blowing space discoveries. Let's blast off into the unknown together. In the vast expanse of space, among the countless stars twinkling in the night sky, celestial events of unimaginable scale and power take place. Events that eclipse entire galaxies and reverberate throughout the universe. Today, we will delve into one such event, the stellar cataclysm known as a supernova. Supernovae are not just fascinating cosmic phenomena, they play a crucial role in shaping the universe. They are responsible for the distribution of elements throughout space, elements necessary for the formation of planets and life as we know it. In fact, it's believed that most elements heavier than iron, including gold and platinum, were formed by supernova explosions. So the gold in your jewelry, the iron in your blood, the calcium in your bones, all of these were once part of a star that was cut short by a spectacular explosion. From ancient civilizations that saw these events as omens to modern astronomers studying them to understand the universe, supernovae have always fascinated us. In the great theater of the cosmos, the stars are the protagonist. They are born, they live, and they die. But some stars give such a spectacular performance in their final act that it outshines entire galaxies. They are supernovae, the catastrophic death of stars. But what is a supernova? Simply put, a supernova is a powerful and bright stellar explosion. It occurs during the last stages of a star's life, when the nuclear fusion in its core can no longer support the outer layers of the star. This causes the nucleus to collapse under its own gravity, leading to a violent explosion that can briefly obscure the entire galaxy. The energy released by a supernova is so enormous, it's equivalent to the energy that our sun would radiate over its entire 10 billion-year lifetime. Long before telescopes, space probes, and modern astronomy, ancient civilizations were already observing the stars. They noticed patterns, mapped constellations, and recorded celestial events. Among these events were the sudden appearances of new stars, which we now know as supernovae. One of the earliest recorded observations of a supernova was made by Chinese astronomers in 185 AD. They described a guest star that appeared in the sky, was visible in daylight for several weeks, and disappeared after about 8 months. We now know it was a supernova, and its remnants, known as RCW 86, have been observed with modern telescopes. Another famous historical supernova is SN 1054 Crab Nebula, discovered by Chinese and Arab astronomers in 1054. This gas star was about 4 times brighter than Venus and was visible during the day for 23 days. The remnants of the supernova, or what we now call the Crab Nebula. The ancient observations of supernovae had a profound effect on the way these civilizations understood the cosmos. They challenged the idea of an unchanging universe, an idea prevalent in many cultures. They were also used for astrological predictions and were often seen as omens. Today, we continue to study supernova not as omens, but as his opportunity to learn more about the life cycle of stars, the creation of the elements, and the history of our universe. Although our understanding of the cosmos has grown, these stellar explosions continue to fascinate us with their power and mystery. Recently, the star Betelgeuse and the constellation Orion have attracted the attention of astronomers. Betelgeuse, a red supergiant, is nearing the end of its life. And at the end of 2019, it began to dim dramatically, leading some to speculate it may soon become a supernova. However, it has since returned to its normal brightness. The most widely accepted explanation for this event is that the star emitted a large dust cloud, which obscured some of its light and made it dimmer from our perspective on Earth. When the dust cloud dispersed, Betelgeuse's brightness returned to normal. This serves to remind us the universe is not a static place, but a place where stars are born, live, and die in spectacular ways. Every star in the night sky has a story to tell, a story that begins long before we see its light. The life cycle of a star is a journey of transformation, from a mere cloud of gas and dust to a beacon of light that can outshine a galaxy. The journey begins in a nebula, a huge cloud of gas and dust. Inside these cosmic nurseries, pockets of gas and dust begin to collapse under their own gravity. When they collapse, they heat up and form a protostar. Over millions of years, the protostar continues to gather mass from the surrounding nebula. As it grows, the pressure and temperatures in its core increase. When the core temperature reaches about 27 million degrees Fahrenheit, nuclear fusion begins. The protostar is now a main sequence star, just like our Sun. In stars the size of our Sun, the core shrinks and heats up, causing the outer layer to expand. The star becomes a red giant. Eventually, the core collapses and the outer layers are ejected, forming a planetary nebula. This leaves a white dwarf. But as we travel through space, we find that not all stars meet their end in the same way. Star can also goes supernova. Its type will largely be determined by the mass, composition of the original star, while also having its own unique characteristics. For example, spectral analysis of type 1, supernova lacks hydrogen lines. The most famous subtype type Ia occurs in a binary stellar system. A white dwarf, the dense remnant of a star similar to our Sun, sucks matter from its companion star. Once the white dwarf reaches a critical mass, it undergoes a thermonuclear explosion, resulting in a supernova. Stars with at least 8 times the mass of the Sun can undergo this dramatic transformation. The core of the star collapses under its enormous gravity. This collapse of the nucleus occurs incredibly quickly, in just a fraction of a second, and leads to a powerful explosion, a supernova. But the legacy of the star lives on. The explosion disperses the elements formed during the life of the star into space, seeding the cosmos with building blocks for new stars, planets, and even life. Did that blow your mind? Supernovae aren't just fireworks in the sky, they're the universe's grand finale. But hey, we're not done yet. We've only scratched the surface of the mysteries lurking in the depths of space. Want to dive deeper into the wonders of space science? Subscribe to Space Episodes for upcoming educational videos related to space science. And press the bell icon. Thank you for watching this video until the end.